Can everyone hear me? Luckily I didn't wear my summery floral dress today, so my microphone's a bit easier. So my name's Connor, and I'm going to talk to you about our research in dementia. And in the 21st century, we all recognise dementia as a big problem facing a society. So I'm not going to dwell too much on the hows and whys of that. But also in the 21st century, there's been another huge change in our society, and that's how much data is available. So what my research is really about is how can we use this big data to give us answers to the questions about dementia facing our society. So I'd just like to start by posing a few statements to you which I can hopefully change some perspectives which I come across a lot in my work. So I'd first like to say we read epidemiology studies every day. And by we I mean you, not me. My granddad thinks that epidemiology is to do with skin, so you might not understand it, but you read it. And secondly, everyone says this to me, data and statistics are all about maths, and therefore they are really, really boring, so stop talking. Thirdly, population aging. We all know population aging, I think. We all understand it. And it means more dementia. Simple statement. And fourth, what does a medical scientist look like? Now, I'm sure most people who come to a lecture on the Faculty of Medical Sciences expect to see this person. He's really happy, he's in his lab coat, he's got his chemicals and doing his thing. But in my work in IHS, we don't really look like this. We don't really look this cool either. But we're associated more with data science. So rather than test tubes and chemicals, I work with math, statistics, and also computer coding and programming. And I'm guessing a lot of people in the room have seen headlines like this. And reading headlines like this and the articles with them, then you're probably reading about epidemiology. Because rather than it being about skin, like my granddad thinks, epidemiology is all about you and me and us as a population. And it's looking at the big picture. So earlier we heard about looking at health and disease and the very, very small. Epidemiology is the opposite of that. A population can be the size of a continent or us in this room. And we're interested in how health and disease patterns change in populations. And to do this, we use data. Now, again, probably everyone's heard of data. It's mentioned in our everyday lives more or less every day. But we don't really think about it in terms of how is it a scientific tool. So how can we use it and as a malleable material, almost? And most people tend to think of a sort of innocuous cloud like the Matrix. But it's not that cool. But data really, it is all about us and you. So data is about people. It's all about information. And we have a lot of information. And especially in the 21st century, we're producing more information about ourselves than ever before. So I just want to quickly touch on dementia and not go through why it's a huge problem. But some of the key facts are things like a person is diagnosed with dementia every 3 seconds. And if it was a country in itself paying for dementia care, it would be the 18th largest economy in the world. And it's not just a problem for us in the West, which we mostly associate with it. 68% of new dementia cases by 2050 will actually come from the poorest parts of the world. So rather than being a scientist in your lab with your chemicals, what does an epidemiology study look like? And we work with a cohort study called the Cognitive Function and Aging Studies, or CFAS for short. And I keep mentioning that it's all about people, and that's true. So we recruited people from 3 sites, from Cambridge, Nottingham, and Newcastle, so here in the city. And we recruited about 7,500 people. And this was done in 1991 and 2011. And everyone who was recruited went through a big questionnaire about their health, their lifestyle, and various health assessments. Some of those people unfortunately died or moved away and couldn't take part, but those who stayed in the study were then followed up for a second wave. So then not only can we see the snapshot of what they look like in the first baseline, but we can follow them up and see how they've developed over 2 years. And the uniqueness of CFAS, unlike a lot of other cohort studies, is the fact that there's two waves. So these cohorts in the baselines, they're two completely different cohorts of people, but they were recruited in exactly the same way using the same methodologies. So this gives us a really unique way of seeing how the elderly population has changed in the 2 decades. So how do we go about conducting my research? So we take all those questionnaires, that information, and then we turn it into numbers. So we quantify it because we want to measure it. And you can't really measure someone's questions on a paper. And we code that into zeros and ones and group it together into things which we find useful. And this is where statistics comes into things, and where most people turn off, because I said the S word. But statistics isn't all about maths. I'm terrible at maths. I have a GCSE in maths, level C, so I'm not great. But statistics is all about how we measure this data, taking all those zeros and ones, that big innocuous cloud, and putting it into terms that we can understand and looking for associations and patterns in the data, which can give us something meaningful. And what the studies were designed for were to look at the incidence and prevalence of dementia in the 2 waves. So for those who aren't familiar with the terms, this is the epidemiology bathtub, which epidemiologists love. And we think of prevalence in terms of how many people at a certain point in a population have a disease. So how full is your bath, more or less? And then we can also look at incidence. So these are how many new cases in a year add to that prevalence. And that's like turning on your tap and letting more water into the bath. So the first question that they asked was, has dementia prevalence changed? So from 1991, it was estimated that there were about 600,000 people living with dementia. So what they did from there, we knew that the population was changing, the demographics were changing. So based on what we knew about population aging, we could then make a projection to what they thought would be the number of cases in 2011. So a bit of a Price is Right moment. Assuming population aging, do we think it's higher or lower? Higher, yay. So yeah, we thought it would be higher. So we estimate there would be about 900,000 people. So this is just visualizing that 600,000 people by their age group. So we have age along the bottom and the proportion that has dementia along the y-axis. And there's a nice association with age. As we've already heard, the biggest risk factor for dementia is age. So we'd expect that. So we're also expecting an extra 200,000 people with dementia. We'd expect all these bars to get much higher with, in the CFAS2 cohort. But this isn't actually what we found. So in almost every age group, the proportion with dementia has actually gone down. So this was contradictory to everything that we used in the predictions. So we then had to reevaluate these, and changing our projection to what we observed was around 670,000. So although the number of cases has gone up slightly, as a proportion of the population, this actually represents a 24% reduction from what the 1991 estimates were. So then we thought, let's look at the number of cases per year and the incidence. So again, we made our projections of 180,000 in 1991 developing dementia over a year. So using that in our age-based projections, again, we projected that there'd be around 250,000 people. So just visualizing that 180,000 again, this is, rather than the bar chart, a nice line graph with your age on the x-axis and the rate at which people are developing dementia on the y. And again, you see this nice curve as dementia is associated with age. So it looks right. And again, we're expecting a jump in the number of people with dementia. So when I overlay the CFAS2 data, we're expecting it to be higher than the blue line. But again, that's not what we saw. So again, incidence rates look like they're down. So putting that on a log scale, just so we can see the differences in the bars, in the lines differently, you can see that in every single age group, dementia incidence rates are down. So we thought, okay, let's look a little bit closer. If the incidence rate's down, is it the same in men and women? So what kind of patterns in society can we see? And here we see a huge difference. So this is men and women in CFAS 2 and CFAS 1. So for women, there's not really that much of a change. It's quite a stable trend. They're down, but we'd expect that from the earlier line graph. But in men, there's a huge difference. So especially in the oldest men, so for those over 85, the incidence rate has decreased from around 70 to a rate of 38. So a huge decrease. So we change our estimates again. So that's 209 rather than the 251 that we actually saw. And again, as a proportion of the population, that represents a 20% decrease in dementia incidence rates. So, as you can imagine, we were really good at being wrong. So, this raised more questions than it did answers, really. So why is this happening? And this is where the power of having these big studies with high statistical power really comes into play. Because we can look at those patterns and see what lifestyle factors that those people related to us in their questionnaires, how does that affect their risk of developing dementia? So we have three key findings. Education. Education, again and again, has shown to be a huge protective factor against dementia. So in most studies that measure it, the more years you spend being educated, the less likely you are to get dementia. Secondly, healthy hearts. So cardiovascular health has again shown to be a huge protective factor against dementia. And between these two cohorts of people with 20 years difference were probably educated a lot differently. There were also huge changes in the way we view cardiovascular health. And the third big thing we found is in men, and more specifically, men behaving like women. So women have been a lot better at living longer and healthier for quite a while. And what we see in the second study is that men are really just starting to catch up. So that's where we see these drastic changes. Men are smoking less, drinking less, and generally have these better cardiovascular health than that which is associated with the risk of dementia. So that's all well and good for dementia and not dementia. But we wanted to go further than this and look at cognition in general. And this is where my PhD really fits into the CFAS group, because I'm interested in mild cognitive impairment. Now, rather than looking at dementia and not dementia, I think in my study of cognition as a spectrum. So as you've already heard, it's normal for our cognition to decline as we age, and that's perfectly healthy. But when it declines to a point where you can measure it, and you're becoming aware of the impairments, that's what we call MCI, or mild cognitive impairment. And the key thing about this stage is it's not necessarily going to degrade further. You can live with MCI for much longer, or the rest of your life, or some studies have shown you can even improve your cognition. So before you get to dementia, where there's no going back really, this gives us a key opportunity to be able to intervene in someone's cognitive health. So you can kind of see that between being diagnosed with dementia, if we say dementia is right at the bottom of this arrow, and being healthy, there's a huge range of cognition in between. And you'd have kind of people who are diagnosed with mild dementia or have other kinds of cognitive impairments in there. So this is from one of my studies using the CFAS 2 data and some of our preliminary findings. And scaled up to around 2020, the dementia group represents around 800,000 people. These are calculated slightly different to the other studies, so the numbers are slightly different, but we're looking at a whole spectrum. And we see that decrease, which we expected to find. And this is what happens when we overlay mild dementia and other severe cognitive impairments. So there's still that decrease, but compared to the 800,000, this represents about 1.5 million. And we're not necessarily saying that these people have dementia, but what they do have is probably very similar care needs. They've still got severe cognitive impairment, they've still got severe cognitive impairment and problems with their everyday functioning. So their care needs aren't that much different to dementia. And they might be in hospitals being missed and not picked up for those care needs. And this is what happens when we overlay MCI. So people in the MCI group are thought to be at very high risk of getting worse and going to dementia. And this is where we really see a reverse in the trend. So far, everything to do with dementia has been going down. But the MCI group is going up. There are more people with MCI than there were. So compared to 800,000, these studies show there are possibly around 1.8 million people who are in this high-risk group with MCI. And MCI is a really interesting group because we can split it up further. So as we heard earlier, different cognitive impairments are associated with different types of dementia. So on the green box here, that is whether you have a non-memory impairment or a memory impairment. Non-memory, we're looking at things like orientation, movement, and speech, and obviously memory. So these are associated with different types of dementia. Vascular for the non-memory, and Alzheimer's for the memory. And you can start to see here the patterns. So we can see a huge decrease in the non-memory impairments. And that also links with what we've been saying about cardiovascular health and the risk of dementia. But the memory here is what we really didn't expect. This is almost doubled. Well, I think more than doubled. So whilst the risks of the vascular dementias could be going down, there's a real risk that the number of people who are at high risk of Alzheimer's disease are actually going up. Now, if these people can improve their cognition, then this gives a unique opportunity to be able to intervene in the context of there being no cure for dementia. So hopefully from my PhD in this study, we can see that looking at a wider cognitive spectrum gives us a lot more information than just who has dementia and who doesn't. So with that, we read epidemiology studies every day. Hopefully you agree. Data and statistics are all about maths and really, really boring. Hopefully you highly disagree with that. And population aging means more dementia. Well, it's a bit hit or miss. So as we know, the cases are going up, that's always going to happen. But what we know now is, as there's no cure, it's not so bleak as what it's often portrayed as. Dementia is modifiable. There are things we can do which have an effect. And what does a medical scientist look like? Well, hopefully what I've shown is that the more data science becomes part of our lives, the more anyone sitting behind a desktop can be a medical scientist. And I'd just like to give a big thank you to my supervisors and everyone who took part in the CFAS studies. Thank you.
Great presentation.
Thank you.
Just one thing that kept looping in my head that when you win the prize and for the next lecture is that between it was 20 years in between the two cohorts. And
yeah.
So I was thinking, have they changed the definitions for dementia? What was the actual classification for dementia in the two groups?
No, well that's one of the things that comes up a lot. So depending on how versed you are with the DSM, how we kind of diagnose dementia. So a decision was made. We could have updated the diagnostic criteria, but on the balance of when balancing kind of the choice between updating the criteria and comparing two different criterias, we decided just to compare DSM-3R, which would have been the 1991 diagnosis, and DSM-3R in 2011.
So they're both classified
yeah,
exactly the same
yeah.
way.
So all of them, yeah.
Four in the second group.
Yeah, so that's what gives it its strength, really, is all of the methodologies into recruitment and all of the methodologies on classification are exactly the same. So nothing was changed.
Okay, so you don't have downgraded them in the second group too, and then it's the same? Okay,
No,
good.
yeah.
Okay. Thanks very much.
Thank you.